Alright, hello. This is assignment 4 on mutation testing. Members is Kimberly, Sophia, Daniel, and Adrian. Mutation testing, this is what I'm going to begin with explaining, is a form of testing code. By the way, it does speak a lot about mutants and about eliminating mutants. By the way, a mutant is a defect. So for this assignment in particular, we're using the PIT test, which is a mutation system that applies mutants, said mutants before, in the Java code we are working on. And this helps assess the testing environment like you see right here. For example, we have a calculator that does simple things such as divide, sum, multiply, subtract. And these are the testing methods of that. And basically, this tool helps assess the testing environment of the said code. And we have here results of a coverage report after it is used. So now we're going to proceed into using it in an IntelliJ format.
So this is our code target, and it's basically just a simple calculator program written in Java using JUnit, and it's testing certain methods in our source file. For example, it's testing the subtract method, the multiply method, and the divide method that you can see here. And we are testing it by using the assert equals method that JUnit provides, and it's just testing to see if the output of those methods are correct.
Okay, I'll be going over the 3 elaborate test cases for our code. In our case, we have the calculator test.java. Inside of it, we mostly have functions of a calculator. So we have test cases for each function. In our case, I'll be talking about subtraction, multiplication, and division. Um, so if after running the coverage metrics in the report, you end up with this page that gives you like a coverage report. The green means that even though it's a different piece of code, they have around the same output. And the red one, it means that it has mutated a little bit. So if we can see over here, we have 3 test cases. So we have the multiplication, the division, and also the subtraction. So as I mentioned, the green one just means that the output for both pieces of code is the same. So it has not mutated at all. And if we jump into the red one, you have the number 1 and the number 2. So this means that one of them has mutated a little bit and it has caused an error in this case. So it means that either it has survived or either it has been killed because of a difference. That's the main um, premise of this tool, that it allows you to identify what parts of the code have mutated. And this is basically the coverage metrics and reports part of it.
Okay, so I'm just gonna go over some of like the basic features of PIT and like how we can use it and what we can do with it. Uh, so PIT's gonna be able to run the unit tests that are given against like different modified versions of your code. When the code changes, uh, one of the best features of PIT tests is that it'll produce different results that will make the test fail. So if we know the test does not fail, we might have issues with the test when these tests, uh, and the test will cause it to be killed, and then so vice versa. In this case, if the test passed. So I guess one of the things we can see is like in this case, the light green shows line coverage. So there's also different ones like the dark green, and it shows mutation coverage. The light pink shows that we have lack of line coverage, and the dark pink shows lack of mutation coverage. Um, this is kind of just what we see like when we're using it. There's also different outcomes of PIT. There's killed and lived, which is kind of explained before, and they're kind of self-explanatory. There's no coverage, which is kind of the same as lived, but the only thing is that there would be no tests that were actually exercised in the code that we used. There's other ones like timeout, which that will mean that we have like an infinite loop in the code. We have non-viable mutation. It's just one that could not be loaded by the JVM as a bytecode, or we could just say it was like invalid. Memory error, which is kind of self-explanatory as well, and then run error, which means we kind of just had a problem. We were trying to test the mutation. That would be it for the features of this.